We have now another example, and this is a real-time Python example, and here you can hear that it sounds quite different from the original because of strong aliasing components. So this example takes the microphone input, it will sample it without removing the zero, and it will play it back in real time. So we'll construct this unit post train using the modulus function. So this is how we are constructing here a unit post train with a 1 at every nth sample. So this was originally an example from Professor Schuler, which I updated, made some improvements, and ported to run inside Jupyter notebooks. So now we have a small GUI. So let's go through the code. So I'm importing these libraries. We are going to use PyAudio to handle the audio. Then we are going to use NumPy. We are going to use IPy widgets to have some GUI, the graphical user interface with some buttons and checkbox. And we are going to use threading to run the audio part inside the thread and still be able to interact with the graphical user interface. So when I run the cell, it will automatically start this PyAudio streaming. So I don't need a start button, but I'm doing here is a stop button. So when I press this stop button, I want to stop. So the stream is going to stop, and I will close. I will terminate the PyAudio instance, and I just print that the PyAudio is terminated. So here I am defining a sampling on that is going to be true or false. So this will control when we press this sampling checkbox, and then we will turn on sampling with this downsampling with zeros. And so this is the defining the stop button. Here is the function that is called when the stop button is pressed, and I'm displaying the stop button. And here is this checkbox to turn on, to turn sampling on and off. And this is the function then it's called when there is some interaction with this checkbox. So here I'm defining that n is equal to 8. This is the downsampling factor. Here I'm creating the unit post train using this modulus function here. So there's a 1 in every nth sample. This is what we are doing here. Here I am using the PyAudio now in callback mode. So if you've been following our tutorials, you've seen we've been using PyAudio in the blocking mode. So we have this string read, but in this case there will be this callback will be called all the time that we have samples, and then we can do some changes with this data, and then also to playback. So this is here we're creating an instance of PyAudio. Here we are creating the string, so we are using 16-bit integers. This is one channel, so it's mono. Here's the sampling rate we are using, output true and input true, so it means that we are using the microphone input and the speaker's output. We are using 1024 frames per buffer, and then we have this the callback function that this is. So every time we have enough samples, and then this callback will be called, it will execute. And there's recommended by PyAudio to have this keep alive function here. So we use the while this stream is active, it just sleeps, and I'm just including here this stop. So when we press stop, also interrupts this infinite loop here. Finally, I'm using a thread to run this keep alive, because as we have an infinite loop here, and I don't want it to block, and we're not able to interact with the graphical user interface. So this part runs in a separate thread, and the PyAudio, when we are using also the callback mode, is using another thread. So here I'm starting the stream. Actually, I don't really need to use this because by default, if you don't put that the start stream is false, when you create the stream by using the spy audio open, it will already start, so this is not necessary. And then I'm starting the thread to have this keep alive. So let's execute the cell. Allo som, A test, check 1, rock and roll, heavy metal, jazz and blues. So now we're going to turn on the downsampling with zeros by a factor n equals to 8. And now we have the downsampling version with the zeros on. Rock and roll, hey, check, blues, jazz, funk, soul, rock and roll. And now back without the downsampling. So we can see the aliasing components. And if we stop, the pi audio is terminated. And this was our real-time example, just to take a look what happens with downsampling without removing the zero.